Welcome to our session, full room today, great to see. My name is George Elissaios, and I'm a Senior Director of Product Management, leading our AI ML infrastructure portfolio here at GCP. Today we're going to cover how Google Cloud will help you build your organization's AI future. I will be joined today by three incredible speakers. Paresh, Kharya, who's leading product for a number of our ML IaaS products. Omer, Hasan, VP of Operations at AppLovin, that is building a powerful AI-backed ad engine. And finally, Mile Ott, founding researcher at Character AI, one of the most innovative AI companies in the world today. So we have a full session and a lot to cover, so let's get started. It's really not news to anyone in this room that in the last 2 years, we have seen leaps of progress in the field of machine learning, perhaps best portrayed by the revolution in generative AI. Probably most of you also know that Google's research and technology is at the heart of this revolution in multiple ways. It is really no exaggeration to say that AI is in our DNA. Google's AI DNA also directly impacts and enables Google Cloud customers in really multiple ways. Through industry-defining AI R&D that pioneered products like transformers and TPUs, or through leveraging our experience of building our own models, training them and serving them, and taking those experiences to enable our own Google customers to build and fine-tune their models. And of course, by continuing our long history of open source contributions to influential projects like Kubernetes, JAX, XLA, and many more that truly create an open AI/ML ecosystem. And we can't forget our learnings that we get from scaling apps like Gmail and Google Search and YouTube, and how Google Cloud translates these learnings to customer benefit in order to cut down their AI journey and remove any scaling obstacles that they might face. And you can really see that AI DNA reflected in Google Cloud's infrastructure that we make available directly to customers. An efficient, highly available, performant, and secure infrastructure at scale. Whether that is with purpose-built compute, best-in-class networking, or a sustainable and efficient data centers that run on green energy, we really think that Google Cloud is unique in offering so many advantages to AI customers. And it's therefore no wonder why AI customers overwhelmingly choose Google Cloud for their workloads. In fact, 70% of the most innovative generative AI organizations have already chosen Google Cloud as their platform. Customers like Anthropic, AI2, Runway ML, Character, Cohere, and so many more build and serve their models on GCP. And of course, also build innovative products, from AI chatbots to advanced video editing capabilities, to new marketing tools, and so much more. But it's not just organizations that were built to do AI that make GCP their platform of choice. It is really customers of every conceivable vertical or use case. For example, LG uses TPUs to train their own large language models. Or in the financial services industry, customers that do fraud detection or risk management, like Goldman Sachs and Wells Fargo, run on GCP. In retail, our customers build some of the most advanced and accurate recommendation engines out there, like, for example, Walmart. And in manufacturing, customers like Ford and GE, with predictive maintenance capabilities and with quality control systems, leverage GCP's AI infrastructure. And of course, you have media and entertainment and so many other verticals. For example, Snap and Midjourney, some of the most innovative media and entertainment customers out there, use both video and images to generate content that is consumed by billions of users daily, all built on Google Cloud. And we, on our side, are truly fortunate to be working with thousands of these customers every day and helping them leverage AI to achieve their mission. And of course, we get a lot of learnings from understanding their needs. And our advantage is really applying these learnings in order to build a comprehensive machine learning stack that ranges all the way from infrastructure through software and up to services, allowing you to consume exactly where it's best for your application. For example, let's say you're producing a foundational model from scratch. Google Cloud is unique in offering you best-in-class choice among best-in-class AI supercomputers based on both GPUs and TPUs that scale to tens of thousands of chips. Or let's say you're fine-tuning models. You probably need to manage large and complex data sets. GCP platform services like Google Cloud Dataproc, Dataflow, and BigQuery allow you to manage multiple different training sets for each one of your customers securely and efficiently. And of course, you could be consuming and serving these models baked into your application. Well, GCP enables everything from the lowest latency serving to the highest cost efficiency inferencing with hardware choices like the NVIDIA L4 GPU or TPU V5e, both of which you will hear more about later today. And of course, you can move all the way up the stack and consume at the Vertex AI platform layer, where we offer managed services that completely abstract away all of the complexity and offer you the fastest path to production AI. But for now, let's focus a little bit on the infrastructure layer, which is the engine of much of the innovation that we're seeing in AI today. There, we can take a quick dive into Google Cloud's accelerated offerings, the GPUs and the TPUs. Let's start with GPUs. Here, Google has a deep and storied partnership with NVIDIA that is allowing us to build an industry-leading cloud GPU platform. The approach we're taking is to provide GPU infrastructure that is best optimized for your workload. And we do that across three main axes. The first one is speed to market. We were the first cloud to bring NVIDIA's T4, and A100 instances to the cloud, and we're still the first and only cloud to have NVIDIA L4 instances offered to our customers. So Google customers can continue to rest assured that they will get early access to the most cutting-edge NVIDIA GPUs going forward as well. And in a fast-changing commercial environment, this can be a huge competitive advantage for our customers. For example, it can allow you to lower your serving cost compared to competitors. The second axis is the breadth of our offering. With 9 different NVIDIA GPUs with flexible VM shapes, we provide optionality that allows you to pick the right configuration for your exact workload, reducing cost and increasing efficiency. This holds true whether you're doing graphics work or you're training the largest large language models out there. And finally, the third axis, to optimize the cloud experience for performance and productivity. With software stack optimizations like JAX and OpenXLA that we brought to GPUs, and by offering scale and elasticity that many of our customers need to scale to thousands of GPUs that work in tandem, interconnected as a single supercomputer. So let's take a quick look at 2 of our latest GPU offerings on Google Cloud. And we'll start with A3, our most powerful GPU instance, powered by the H100 NVIDIA GPU. The A3 VM is designed for your most demanding AI, ML, and HPC workloads. It combines 8 H100 GPUs connected by NVLink, NVIDIA's high-speed GPU to GPU interconnect. A3 achieves 10x the networking and 3x the training performance of its predecessor, the A100, which we made available on Google Cloud through the A2 VM. Our unique, intelligent Jupyter data center networking fabric allows tens of thousands of H100 to be interconnected and work together as a single machine, delivering up to 26 exaflops of AI performance. This level of performance is a game changer when it comes to training the largest AI models. A3 is going GA in the next month, but is already trusted by multiple Gen AI unicorns like Anthropic and Character and Midjourney. Earlier this year, we also announced our G2 VM, which is powered by the NVIDIA L4 GPU. G2 is our most versatile GPU offering and is able to power a broad range of applications from generative AI to graphics to virtual workstations or gaming. It offers significant performance improvements compared to its predecessor, which was powered by the T4 NVIDIA GPU. Let's take a look at some numbers. We've already seen customers achieve 2.5x the Gen AI inference performance for gaming, 3.3x, and up to 4x for digital twin applications. This has fueled real rapid adoption amongst a wide range of customers. For example, Volkswagen uses G2 to power their virtual showroom experience. Bending Spoons achieves lower latency latency in serving generative AI models. And you know, Bending Spoons earlier this year scaled to tens of thousands, 32,000 GPUs in order to bring their application to the top of the App Store. And then you have customers like Workspot that optimize and change really the cloud PC workstation game by improving frame rates by as much as 2x. To sum it up, our strong partnership with NVIDIA allows us to be the first to bring the best GPUs to market, to optimize the software stack so you can get the best out of the NVIDIA hardware, to ensure our customers enjoy scalability and elasticity, something really important for them today, with a huge fleet of multiple GPU offerings. And of course, to deliver optimized, fully managed services like Vertex on top of GPUs. And you can see the value that GCP brings to customers with products like A3 and G2 in the consistency of the testimonials of some of the most influential companies in the AI and graphics space. Well, by now, you probably heard from me enough already. Why don't we hear directly from a Google Cloud customer? Let me bring on stage Omer Hasan, VP of Operations at AppLovin. Let's give him a warm welcome.
Thank you, George, for the kind intro. I'm Omer Hasan, VP of Operations at AppLovin. I've been working with AppLovin over the last decade, heading up technical infrastructure, overseeing DevOps, infrastructure, networking, InfoSec, and IT teams. AppLovin makes technologies that help businesses of every size connect to their ideal customers. We provide end-to-end software and AI solutions for businesses to reach, monetize, and grow their global audiences. AppLovin's mission is to create meaningful connections between companies and their ideal customers. At AppLovin, we have been working hard to upgrade our advertising algorithm with the latest AI techniques. We're using AI to replace human operations, like targeting, setting bids, learning phases, and more, that either our team or our partners used to have to make manually. These updates allow our partners to achieve their goals with greater accuracy and speed on an exponentially larger scale, while saving them time and improving their operational efficiency. With these latest AI techniques, we are seeing early results and impact they're already making for our partners. Our advertisers are able to benefit from the increased automation and recognize better ROAS, or return on ad spend, at a much, much larger scale. Our AI engine, Axon, was first launched in late 2020 and was part of our first stepping stone into Google Cloud. Since then, we've continued to build upon it and expand it. In our latest iteration, we wanted to improve the operational efficiency for our platform for both AppLovin and our customers by moving towards a new accelerator for Axon 2.0. However, we weren't sure what to select given the different number of products available to us. And after consulting with the Google Cloud team, we decided, based on our use case and performance requirements, that NVIDIA Cloud GPUs is going to be the best choice for us. The three main criteria for us were ease of programming, orchestration, performance and latency requirements, and availability of hardware across many, many different regions. We were already in the midst of a large-scale GKE migration, and as our legacy infrastructure was starting to show its age, we felt comfortable launching our next iteration of the Axon 2.0 platform on NVIDIA L4 GPUs, orchestrated by GKE. With the help of Google, we were able to go from an initial discussion to large-scale production rollout in weeks. So how did we get there? Each of our research scientists are able to run their jobs in unique development environments powered by Vertex AI Workbench, which improves our time to develop and therefore our time to market. With training orchestration, we chose Composer, and while this is Airflow under the hood, having it being managed by Google led to durable operational efficiency while leveraging and being able to leverage NVIDIA A100 GPUs to power our new training workloads. We leveraged BigQuery to help with data aggregation to simplify a transition from Dataproc and Spark and into a serverless solution that was easier to query and faster for us. On the inference side, we leveraged GKE once again to scale worldwide across tens of regions, which consistently allowed us to ramp up our business unimpeded by hardware constraints. This step up on the Axon platform led to greater automation and consistency across our application stack, again by leveraging GKE, improving our training time by leveraging the latest GPU hardware like L4s, and the agility by having the flexibility to launch into new regions. Because of Google Cloud's deep commitment to AI technologies, the advancements in our platform have been possible. Thank you, everyone, and on to you, Paresh.
Thank you, Omer. What an amazing story of using a whole host of Google Cloud technologies to fuel recommendation systems. And one of the technologies Omer talked about was Google's Cloud GPUs. Earlier, George talked about how we work very closely with our partner, NVIDIA, to optimize GPUs on Google Cloud. In addition to Google Cloud GPUs, in order to enable even more choice for our customers, we also offer on our cloud our homegrown Tensor Processing Units, or TPUs. Now, before I deep dive into TPUs, let's take a step back. Modern generative AI is transforming computing. Larger and more complex models are basically creating a lot of capabilities across a whole range of use cases and fueling some amazing applications. But at the same time, this complexity and the scale of these models that creates a massive computing demand. In fact, the computing budgets have grown astronomically. If you look at some of the state-of-the-art models today, training every single one of the state-of-the-art models can take up to tens of millions of dollars of computing budget. And when you deploy these models in your applications, the costs can run into hundreds of thousands of dollars per day. At Google, we are, of course, no strangers to this phenomenon. We realized almost a decade ago that if our users searched using voice for just 3 minutes a day, Google would need to double its data center capacity. It's with this realization we created our first TPU. And since then, the pace of evolution, the pace of innovation has dramatically increased. Today, TPUs are supercomputing scale AI systems. They are powered by purpose-built chips created from grounds up by Google. And they are interconnected by some of the industry's fastest optical interconnects. And they are deployed at extreme efficiency using liquid cooling in our data centers throughout the world. In fact, some of the most popular applications and services that you're familiar with, including search, YouTube, and Gmail, as well as some of the most commonly known models at Google, like Palm and Lambda, they are powered by Google's cloud TPUs. So let me take you behind the curtains to see how the Google TPUs look like today.
Today's AI applications are powered by something you almost never get to see: purpose-built AI infrastructure. And while we're operating this infrastructure at planet scale, it all starts with the chip. Google's Tensor Processing Units, or TPUs, are custom-developed, application-specific integrated circuits, also known as ASICs, designed to create at-scale supercomputers that handle some of the world's largest AI workloads. In fact, we believe in TPUs so much that we use them to power some of Google's popular services, including photos and search. The real magic happens when these chips are all interconnected using our custom intercore optical interconnect to create a single supercomputer capable of utilizing thousands of these chips to handle some of the world's largest inference and training workloads. Utilizing the power of our data center networking, we can create large-scale versions of such supercomputers consisting of hundreds of thousands of interconnected chips. Google has taken a step further and utilized optical circuit switch technology that allows these supercomputers to reconfigure themselves and create efficient machine shapes and sizes for your workload, scaling up or down on the fly as needed without any human interaction. This is all made possible by our state-of-the-art OCS software infrastructure, optimized for efficiency and speed. Our vertical power delivered to these supercomputers is cooled by our latest generation water cooling system that is designed with sustainability in mind. All this technology has the attention of our dedicated team of data center technicians and friendly security personnel who are there to guide through our various security protocols, like the biometrics verification through iris scan. All of this operating at the scale of our entire planet, because we believe that AI is for everyone. So we're building the magic to make it happen and giving you an opportunity to build even more on our Google Cloud TPU platforms.
Wow, aren't the TPUs stunning? Earlier today, we announced the next iteration of our cloud TPUs, the TPU V5e. TPU V5e is our most cost-efficient, versatile, and scalable TPU to date. First is cost efficiency. If you're training large language models and generative AI models, TPU V5e would provide up to 2 times more performance compared to our last generation TPU V4. And for serving these large models, you can expect up to 2.5 times higher performance for every dollar. Second, it's incredibly versatile. In addition to doing both training and inference, TPU v5e is available in 8 different VM shapes. And these shapes allow you to have a combination of computing capacity and memory capacity. So you can fit a full range of models. If you're looking at serving large language models, you can fit models up to 2 trillion parameters on TPU v5e. And finally, it's a TPU, so it surely can scale. In combination with our multi-slice scaling software, TPU v5e can scale to tens of thousands of chips to allow you to train the largest models incredibly fast. And on top of that, all of this scaling is available on top of the same out-of-the-box XLA programming model that you're already familiar in using on the TPUs. So what does that mean to you? 3 things, really. TPU v5e allows you to train and serve models faster, more cost efficiently, and also more productively. Now, I know all you technophiles out there are craving to see the details of the architecture. So here they are. TPU v5e is not the largest TPU that you've ever seen, but it's certainly the most efficient. In a world where we are confronted with global AI chip shortages, we've decided to think differently about the architecture and how we serve our customers. We've chosen to make every chip count. So TPU v5e, while not the largest chip, it surely packs a punch. Every single chip carries almost 400 trillion operations per second of AI performance. And in combination with its incredibly fast interconnect of up to 1600 gigabit per second, we can have up to 256 of these chips work together as one. And further powered by our intelligent Jupyter data center network that George talked about earlier, at 6.4 terabits per second per pod, we can string together hundreds of these pods to enable tens of thousands of chips to work together to train a single job. This elegant architecture allows us to offer cloud TPU v5e at an incredible starting price of just 54 cents per chip hour. And starting today, TPU v5e is available in our North American region with availability in APAC and EMEA coming soon later this year. In fact, if you go to the hardware wars, you can check out the full rack of TPU v5e that we are displaying there. To enable our customers to take full advantage of TPU architecture, we've also invested heavily in the complementary software stack. You can use all the popular frameworks like TensorFlow, JAX, and PyTorch to both train and serve your models now on TPUs. This allows you to have one platform for your end-to-end training to serving pipelines. And secondly, we are bringing 2 new scaling technologies. First is multi-slice training. Now, training models across thousands of chips is extremely complex. You need to distribute the models and do parallel training. There are different kinds of parallelism techniques like data parallelism and model parallelism. So our technology, multi-slice training, simplifies all of these parallelism techniques and enables you to scale your jobs to tens of thousands of chips. The second technology is multi-host serving. Because some of the larger models and state-of-the-art models are so large, they cannot fit the memory capacity of a single chip. So they need to be distributed to multiple chips. And multi-host serving allows distributing models to multiple chips while enabling efficient serving. And both of these technologies are available on top of our familiar, out-of-the-box, XLA-based programming model. And last but not least, one of the very highly requested features and capabilities by our customers, we are bringing native integration with Google Kubernetes Engine for TPUs. So you can now seamlessly orchestrate your applications, whether you're running serving or you're running your training pipelines across tens of thousands of chips. And if you want to do fully managed training and inference pipelines, you can use our Vertex AI integrations. This combination of a very elegant hardware and out-of-the-box software basically means that you can have your developers be very productive, and you can deploy latest state-of-the-art models while also being cost efficient. Now, if you take the TPU v5e for a spin, what do you expect? A bunch of bar charts. But I'll make it easy. There are 3 bars for every application in this chart, and we are basically comparing TPU v4 with v5e, and we've normalized to performance per dollar. So if you're training using the common 16-bit bfloat 16 precision for a model of size 32 billion parameter, you can expect up to 2 times more performance per dollar compared to our last generation TPU v4. And if you're training a larger 175 billion parameter model, you can expect up to 50% more performance per dollar. And using a new technique that we are introducing called accurate quantized training, or AQT, you can actually leverage 8-bit integer precision to further boost this training performance by up to 25%. The second chart basically shows what to expect when you scale these applications across tens of thousands of chips. There are 2 lines on this chart, and we had to be very careful to choose the colors of these 2 lines, because otherwise they would look indistinguishable. One line is the perfect scaling, and another line is measuring what we expect you would get as the performance when you scale your jobs. In combination with the multi-slice training that I talked about earlier, you can expect nearly linear scaling of performance of your applications. And so what does that really mean? Model training that used to take months can now be done in weeks. And while you're accelerating the time to train these models, you're also saving money. Now, here are some more bar charts. You take TPU for a spin, and it spits out a lot of bar charts. This time, this is inference. And thankfully, there are only 2 bars for every application. So we're just comparing TPU v4 with v5e and doing performance per dollar. The chart on your left, basically you're seeing performance across the range of some of the most popular large language models. Meta recently released Llama 2 models. And so you're seeing on the range of these Llama 2-based models, you can expect up to 2.5 times more performance for every dollar when running inference using TPU v5e. Also, there is a stable diffusion in there, which is used for generating images, and there's GPT-3 175B. But while you're getting this amazing performance to price efficiency, you're not compromising on latency. In fact, TPU v5e enables all of these complex models to be also inferred incredibly faster, providing up to 70% faster speed up. So in a nutshell, what does all of the things that I talked about in the TPU section, how does that translate to you? 3 takeaways. First, TPUs are a legitimate platform to serve your generative AI applications. Secondly, TPUs are designed to deliver very high performance per dollar. Third, the learning curve on TPUs is very small, because you can use the same tools that you're used to using for developing your application and get out-of-the-box performance from TPUs. So it's no wonder that our customers are really excited about TPUs. Anthropic is looking forward to benefiting from the price performance to fuel their next wave of AI. Crayon is able to train their models faster and more cost-effectively. GridSpace is seeing a 6x higher performance improvement compared to the prior generation they were using for speech recognition and emotion prediction models. And to talk more about the experience Character AI is having, it's my honor and privilege to welcome Mile Ott, founding researcher of Character AI.
Hi, everyone. I'm Mile Ott, founding researcher at Character AI. So Character is a full-stack, direct-to-consumer social AI platform that lets anyone create and interact with lifelike AI characters. Since launching our product about a year ago, we've seen tremendous growth and really creativity from our community of users on how they use Character, with use cases ranging from creative writing help to language learning to entertainment and role-playing, and even sometimes emotional support and friendship. So today, the Character AI community has 20 million users, and millions of those users sign on daily and use the application for, on average, more than 2 hours per day. And so that's really a testament to how much value our product is providing to users. Under the hood, our AI characters are powered by large language models. And so at Character, we pride ourselves on being full stack. And so what that means is we train our large language models ourselves in-house from scratch, and we serve them to our community at scale. And so that introduces really interesting scaling challenges. And so today I want to talk a little bit about some of our recent experience scaling up those workloads and why I'm so excited to be doing that work on GCP. Okay, so historically Character's we've trained our language models on large GPU clusters. And these training runs will often consume thousands of GPU accelerators for a month or longer. And because of that, we've spent a lot of effort optimizing this workload, including really low-level details, everything from writing custom CUDA kernels to optimizing the distributive collectives that we're using during training. More recently, we've explored, we've asked basically, can we train these language models on cloud TPUs? And we've been really just blown away with how quickly we've been able to onboard on this new platform and start using TPUs productively. So in under a month, we were able to port our highly optimized PyTorch code base into JAX and start using many smaller slices of TPUs in concert with technology called multi-slice XLA, which allowed us to scale up much faster than waiting for a single large contiguous block of compute to become available. On top of that, TPUs integrate natively with GKE and allowed us to kind of reuse a lot of our existing Kubernetes-based tooling. And so that's allowed us to really build a kind of uniform platform across GPUs and TPUs for our researchers to use. Which brings me to sort of my favorite part about Google Cloud, which is the flexibility that it provides. Because we can use either GPUs or TPUs for our workloads, we can also start to map our workloads to the platform that best, is best for that workload. And it's still early days, but we're finding that GPUs are great for high throughput applications, settings where you really want to squeeze every little bit of performance out of the chips and are willing to do kind of these low-level optimizations, things like writing custom CUDA kernels and like that. TPUs, on the other hand, with their very fast interconnects, have been great for applications like low latency inference and use cases where you may not want to really kind of prematurely optimize, and you just want kind of decent performance out of the box. So research and development kind of applications. We're also really excited about next-gen accelerators, and we heard a little bit about those earlier today, but the H100s and V5E. These accelerators offer a lot of technical improvements, but one that we're really excited about is both platforms support now native 8-bit training recipes. So on TPUs, we're going to have AQT with int8, and on H100s, we're going to have FP8 with Transformer Engine. Altogether, we're finding in early tests that these new chips are going to provide roughly 2x better performance per dollar. And that's really exciting for us, because it means training language models is going to be easier and cheaper than it's ever been before. And especially as we look to growing character to hundreds of millions and billions of users in the future on Google Cloud. We're really excited about this. So with that, I'll pass back to Paresh to close this out, and thank you.
Smile. You just heard from Mile firsthand how Character is able to use both our cloud GPUs and cloud TPUs to power their applications. This is our superpower. We are the only cloud on the planet to offer two incredibly compelling platforms for doing your AI workloads. And we offer a whole range of instances, so you can fit the right choice instance based on your workload. Whether you're looking to inference on the small models, or you're looking to train the most massive ones, Google Cloud has just the right choice for you.